So today I'm going to be taking a look at the Curfboard surf truck, the ultimate surf skate truck. So the Curfboard was a design that launched on Kickstarter about a year ago. It was successfully funded, and I believe they started shipping out product about 3 or 4 weeks ago, and you can just order it online from their store at this point. So it's gone from Kickstarter, and just up to very recently, it's an in-store product, which is really cool. So the design is really interesting and unique. If you take a look at it, you can see it's got these two armatures that attach to the hanger, and that it doesn't have any bushings or any means of resistance built into it at all, from anything you can tell. It's got these 4 pivots on either side of these armatures, on these 2 arms, so 1 pivot on each end of the 2 arms. And as opposed to what a normal truck would have is just a single pivot. So there's quite a few interesting things going on. It clearly is something a bit different. They also make a few interesting claims in their video and in their media. When they make an emphasis on the fact that it has a raising center of gravity during a turn.
In a curve, the curveboard deck is now lifted and gravity replaces the rubbers or springs as a restoring force.
I think that's really interesting. There's not a lot of trucks that have that to any meaningful degree. And, and that's of special interest to me because, back 8 years ago when I was helping with the Other Planet stuff, that was kind of our big emphasis. Our emphasis was we had the raising center of gravity. I remember when I was going through and designing all those early YouTube videos, we came up with all these ideas to pitch, and we came up with this, we're like, I have this slogan that's down with the Kingpin, and we'll emphasize that it doesn't have a Kingpin, it's not a Kingpin truck. And here on their official media, they also emphasize it has no Kingpin. And I thought that was really interesting, that shares a lot of parallels with this truck that I worked on, but it's achieving it with this completely separate mechanism. So I was just totally intrigued by that. Some of the claims it has is no speed wobble on the front truck, perfect control, precise response, no adjustments of bushings or springs, and self-regulating depending on the rider's style and weight, and no wear of bushings and replacement parts. So I'm going to take a look at some of those claims and kind of breaking things down and kind of sharing all this stuff I found when kind of exploring how this truck works. But unfortunately, the bad news: I don't actually have a Curfboard truck in my possession to mess around with. So I had to make this model right here of a Curfboard truck with connects. And so let's take a quick closer look at this, and I'll explain what's going on. Alright, so this is my Curfboard model of science. And this is what I used to do all my experiments with and such. And I believe the distances are actually all pretty relatively accurate for the armature length and the distance between this gap here and the gap there. I think it's all actually pretty close. But to help you visualize what's happening, I've tried to use the white pieces to represent what's the actual physical part of the truck. So this white across here would represent the hanger and axle. So the axle will be at the end, and the wheels will be there. It'd probably be a little wider. The axle would be wider than this, but there you go. The base plate would be this section up here, and the armatures are those white pieces there. So that should help you visualize a little bit. Normally it would be hanging like this on the deck, and it would be trailing like that. But here you can kind of get an idea and see it a bit better. So if I grab this hanger and I lift it up, you can clearly see that this center point is actually gaining height, and it's raising up. So it does have this raising center of gravity, like they say, and it works out pretty well. But you'll notice that it's got this wider section here on the hanger and this narrower section there on the base plate. And I was wondering, of course, why would you need to do that? And so I made another model. And it's kind of interesting and, kind of obvious at second glance. But if the arms are the same size, all you get is a parallelogram. And if I try to twist the top, it wants to twist the whole body. And you can't actually, it's not actually a pivot. It's just a parallelogram, not a pivot at all, which won't work for a truck. A truck needs to be able to pivot. I need to be able to twist this top part of the hanger and have it twist independently of the base plate. So I thought that was kind of interesting, that you can't have the armatures be the same width apart from each other. You might notice, but this is actually a little plotter. So I wasn't just fiddling around. I was actually using this as a plotter to actually draw out the path of the axle. So I'll do that for you real quick as a little demonstration. So using this model as a plotter, I'm able to draft out the axle travel path. And you can see here, this is at the bottom of the travel, and as it rotates, this is going to be like you leaning the deck. As you lean the deck over, I'm able to get a measurement of how much height you're getting for each degree of lean, and look at where the center of the axle is for the entire travel of it. And I'm able to take a really careful measurement, and I've plotted that out and on another sheet here. So let me swap-a-roo here. So this is the plot I ended up with, and I've got a couple different things on here. The green is the travel of the Curfboard. This outer black is just what a circle is, just a raw circle. And this red is the axle travel of Another Planet truck. So Other Planet is a different truck, which is one actually I helped make way back in the day. That also has a raising center of gravity mechanism. And you can see here, as this rotates, the center of the axle here raises. But it does it through a completely different mechanism. And you can see the shape of the travel is completely different. So basically, so the ends, so at 22 degrees of rotation, the axle travel goes to this point here and this point here, which correlates to a 16 millimeter raising center of gravity on the Curfboard and a 19 millimeter raising center of gravity on the Curfboard. But the Curfboard has a longer travel than 22 degrees. I didn't measure the actual angle it's at, but it's something a little past 30, and it has a theoretical maximum of 42 millimeters. So, not that that's all super really important or anything like that, but the real interesting part is on the path right here. So, the flatter the line is, so the more horizontal the line is, the less it's going to raise per degree of lean. And the more vertical the line is, the more it's raising per degree of lean. So you can see the Other Planet here, it starts off really vertical. So at the beginning, at center, at neutral, it's raising a lot per a little bit of lean, and then it's tapering off. Whereas the Curfboard is the opposite. It's starting off basically with a flat line. And it's only once you get past the edges that this line starts to become more and more vertical, meaning that you're going to have more raising center of gravity as you're leaning the deck more rather than at center. And I thought that was really, really interesting. That means that gives it a completely different feel to the raising center of gravity of the Other Planet trucks. Just completely different. The Other Planet trucks are kind of, what they're trying to do couldn't be done with that design. And I think this way of doing things actually benefits the Curfboard as a surf truck. And the reason why I say that is it means this profile will mean that at center, riding flat, it's going to feel like you're riding on a pivot, like a Kingpin style truck, which means it's going to be really responsive and fun right at the center. And then as you go out to the edges, you're going to feel it want to return more strongly. So it's going to be really active and quick at center, and not necessarily divey, but just active and responsive and quick. And then you're going to feel this raise come into play as you get at the edges. The other Planet, it's more... one of the things it's got going for it is just real strong stability, and so it's just got this really strong center where it's almost more work to get out of, and then once you're out of it, that raising center of gravity tapers off, and that kind of might be an explanation of some of its behavior as well. But anyway, my conclusion with this is that's probably suitable for a carby surf style truck because it allows you to have a more active play at center. So these distance raised here, these measurements for the 19 and the 16 millimeters, that's as if the trucks were pivoting vertically, like I was having in the model, where the hanger was just hanging and swinging vertically. But trucks aren't vertical, they have a pivot angle that's offset from vertical. And that changes these distances in real application. So that's why we've got this second graph here. And this shows that distance applied to their pivot angle. So how this works is, so if I take this distance raised from the Curfboard here at 22 degrees, and I measure that distance, right? And then the Curfboard is, I believe, I didn't get a perfect measurement of this, but I'm pretty confident it's at least 60 degrees. So that's what I'm measuring here. So I take the line and I rotate it 70 or 60 degrees off vertical, and I apply that measurement from before here. I get this new height, which is this green line here. So that's the amount it will raise for that same rotation at 60 degrees of pivot angle. And the OPs, they've got a really, really much lower pivot angle, which gives it a much higher raising center of gravity. And the pivot angle is what controls how much the truck turns. So the OP is not very turning at all. The Curfboard, as a surf skate truck, they want it to pivot a lot. So this is a trade-off for making the truck more turny. You could never use an OP as a carby front truck at 17 degrees. So that's just another consideration for the raising center of gravity there. So this is all pretty abstract. What is this really telling us? So as I mentioned before, this kind of tells us that I think that the Curfboard is going to have a more playful center that's going to be really responsive and turny. But it also has this, it shows this side-to-side motion. You see I just addressed before the raising center, which is the vertical, but this side-to-side motion, that is a factor as well. Surf skate trucks all tend to swing side-to-side a lot. And especially if you're emulating snowboards, not as much, but when they're emulating surfing, that's a big factor of getting that feeling, I think. So that big side-to-side motion is part of that surfy feel. You can see the OP doesn't move side-to-side nearly as much. And I mentioned before, it's got that flatter center instead of this more vertical center, and that means it's going to have that, it's not going to have that raising center of gravity at the center, meaning that it's going to be really, really turny and responsive there. So that's what that means. But to break this out and make it less abstract, I went further. I made some more models. Check this out. All right. So this is my model complete board with the Curfboard trucks at the front, a normal Kingpin truck on the rear, and you can see as I lean the deck, the thing really turns, and it really works. So if you're having trouble visualizing it before from the model and the drawings, this should hopefully help clear things up. So here you have that's the same armature system I had in the model. It's raked back at about 60, oh, this one's not 60 degrees, this one's 45 degrees. So it's less turny than a real Curfboard would be, but 45, that's good. And the rear is 45 as well. So this is the functioning model. This is the deck, and these tires on the stick represent the weight of the rider. But I also have this model right here. And this is what a normal truck is, a normal longboard with a Kingpin on the front and a Kingpin on the rear. And this guy, if I turn it upside down and I turn these, they do not return. They just stay wherever I leave them because there's no return to center. There's no raising center of gravity. So, let's take a look and see how this performs. And let's test some of their claims about these trucks. Alright, so this is what we got. We have the model here, and it's on a treadmill. And what we're going to be able to do is we're going to take a look at, how it handles speed, what its stability is like, how it handles speed wobble, and how fast it can go. And so that's why I need to have this weight on top of these models, so it can act like a real longboard does. The system isn't complete, especially at this small scale, without some weight representing the rider. It just won't work the same. So, let's take a look, and first off, let me explain some things I know about stability and speed wobble. From my testing that I've done in the past, I've concluded that for the most part, your turning characteristics come from the front truck, and your stability characteristics come from the rear truck. If you're building a truck or a setup and you want it to be stable, you get a lot more bang for your buck putting stability in the rear. And if you want it to be turny, you get more bang for your buck making it turny in the front. So the Curfboard has all this advantage of having this really turny, fun system in the front, but my prediction approaching this was that I wasn't sure how much stability it would get with the raising center of gravity in the front and nothing in the rear. But we'll see how that pans out with my test. So let's take a look at the normal skateboard, just kind of get a baseline of how it behaves. So, alright, so right now it's at 3 miles an hour, and this is actually right in the center of its stability zone. You can see, even though it's in its stability zone, it is having it is doing a little bit of a shimmy, so just really very minor wobbles. But if you look, if I push right here, it's able to recover. If I was to push here normally, so if I take it down real quick to 1.5, if I push there, it's just going to keep going off just with the light touch, and it's not going to return to center at all. So 3 miles an hour is actually right in its stability zone. So I can, see how well it recovered from that? Kind of overshot a little bit, but yeah, that's what I mean. It's in its stability zone. Is if it gets disrupted, it returns all by itself. It doesn't really overreact that much, but you can see it's not all that stable. I can take it up to about 3.2. I think it's still in its zone. Yeah. Oh, but you can see it's starting to get a little wobbles. At about 3.4, it exits its stability zone, and it's become inherently unstable at this point. And you can see, see, it's able to recover still. Sometimes. But it's really not stable anymore. So about 3.4 mile an hour is what this guy can do before it's not stable anymore. So let's take a look at the Curfboard and see how that does. Alright, so we've gone straight to 3 miles an hour, and one of the biggest differences is that it doesn't drift anymore. It stays going in a straight line, it stays at center, and it doesn't deviate from that at all. It's staying right in the center of the track. It's not deciding to go over here or just, you know, waving around. Its center is much stronger. But you can see at 3 miles an hour, it's already got a little bit of speed wobble, which is a little bit confusing. But I think the reason why is because of the side-to-side motion of the axle. So if we look at my drawing here, I mentioned that it's got this side-to-side going on. Well, a normal truck, it just pivots around a single point, and according to the way I've drafted this off, it wouldn't have any travel at all. It would just be a fixed dot. And I think that side to side is what's causing it to do this. So even though it's got the raising center of gravity, it's also got the side to side, and it's not just that, but because of the way that this Curfboard is designed, at the origin, at center, the axle path is completely horizontal with no raising center of gravity here. So it doesn't have the advantage of having any raising center of gravity to keep it stable at the very low lean angles. The raising center of gravity only comes into play really as this angle gets steeper from it leaning further. So I think that's the reason why we're seeing this. You can see it's a lot more predictable, and you know, it's getting speed wobble. You can see it's getting speed wobble, but it's different than the way it was happening on the other board. And look at this, I can reduce the speed to 2.7 here, and you'll see it just calms right down, and it will straighten itself right back out, and then it's gone. It's gone all by itself. And if I go to 3.5, 3.5 might be a bit too much for it. So we're at 3.4 miles an hour now, and it's running true here. But if I give it a little speed wobble, you can see it kind of stabilizes. It will eventually kind of trip up here, but it's pretty stable at 3.4 still. It is getting speed wobble, but it's not, the threshold between getting speed wobble and completely losing it is pretty big. See, there it goes. Whereas on the other truck, you know, the instant it got speed wobble, it was basically too late. It was gone. So it's a kind of interesting little difference here. There's one other idea I wanted to test, and you can see if you look at the Curfboard, see it's got those two pivots, and I want to figure out what happened is if instead of two pivots, you just had it rely on a single pivot, because I just wasn't getting, you know, what the benefit of the two pivots was over a double pivot, because or a single pivot, because a single pivot would give you a circular radius, which is just a little bit different from the radius of the Curfboard, or the axial travel path, circular instead of this weird oblong shape. So I made this, and as you can see, it's got one arm, it's pivoting around the one point, and it's got this armature length that's the same size as the other model I was using with the Curfboard, but it's just the one arm instead of two. And I realized something really interesting. So if I take the wheel off so you can see the axle a little bit better, this is basically a Kingpin design. So I've got here the Kingpin on the rear, and it rotates like that along this axis in that direction. This guy is rotating on a single point in an axis in this direction. The only difference is that it's got a ton of trailing rake. So that's ultimately the mechanic that the Curfboard is using to get its raising center of gravity, is trailing rake, which is a mechanic that can be built into basically any skateboard truck. The difference is that on a usual typical truck, the rake is only a couple millimeters, where this is like, you know, almost 2 centimeters or something. So it's a lot more rake, but that's where the raising center of gravity is coming from. A mechanic that's already found in a ton of different options already. So that's what I achieved with this guy. It's just the same trailing rake without the double armatures. So I wanted to experiment to see how this behaves on the treadmill. All right, so we're starting it off at 2.7 miles an hour. So that was about the speed wobble threshold of the Curfboard model. Anything at or below 2.7 miles an hour, and it would depropagate speed wobble. So let's see how this guy behaves. So I can be gentle with this. I'll give it a little tap. And it's able to see it went over and then it recovered. So at 3 miles an hour, if I give it a disruption, it's responding even stronger. It has now got a much stronger stability than it had at 2.7. That was a bit too drifty on it. So 3.1, I actually think it might be within this with speed wobble threshold here. It's just really close. And it just drifts too much. There's a lot of behavioral difference between this thing and the Curfboard. And this axial travel should be correlating with this guy here, just the offset rake board, and the green one should correlate with the Curfboard. And you can see that the lines are really similar, and yet there seems to be more difference in what they're doing than can be explained by just that line. And I think the explanation for that is as simple as the fact that when you have the two armatures, it's just a much more rigid structure. And I think the connects exasperates that issue, but I think it would still really definitely be there between, you know, if you were to make an aluminum truck. So I think the advantage of having the two armatures over the one pivot with rake is just that this is a much more robust geometry, and a lot of, I think, the behavior of this one is just due to the fact that it's flopping and flexing and taking up energy in that sense. It's able to twist and bend and do all sorts of stuff that the Curfboard one just doesn't want to do. And if you were to do a single pivot like this with a Kingpin truck, like a TKP or an RKP, and just have this big offset on it, it would be as sloppy as this thing is because of the way that a bushing holds the truck together. It would be really synonymous with this guy. But the Curfboard, not having bushings, having fixed pivots, I think really benefits its mechanical predictability, and that's what gave it that huge threshold of saying, you know, oh, I'm wobbling, but I'm not, you know, building out of control. It's not propagating. It's either depropagating or it's propagating, and the threshold was all really wide for everything. It has a big stability zone. It has a big, you know, speed wobble propagation zone, and I think that's probably all for the better. Alright, so we've had a look at the trucks in a more abstract and a less abstract way. We've gotten a chance to mess around with some models and get a little bit of intuition about how they probably are going to feel and what they're going to do. So let's revisit our list of attributes and pick apart again and see what we think after learning a few things. So, let's see. First one was the perfect control and precise response. I think we have to give that to them with the dual armatures and the 4 pivots. It's basically a triangle structure, and it's pretty rigid, and I think that's, like I mentioned before, which is the last segment of the video, that I think that's what contributes the difference between the Curfboard and just a normal Kingpin board with all on a brake. That's what it gains there, and that's what the advantage is. That's quantifiably what you're gaining with the Curfboard over existing technology that's just gone a little extreme. So yeah, I think that's probably a true enough statement. I can't really say anything against that. The no speed wobbles on the front truck. That's the one I expected to have the most problems with. Approaching the Curfboard from the beginning. Like I said, speed wobble I don't think is a feature of the front truck. I mean, it might come from the front truck, but it's not inherited from the front truck. The speed wobble and the stability characteristics are, for the most part, inherited from the rear truck. So if you want a stable board, you put in a stable rear truck, and you can have a wildly unstable front truck and you have a stable rear truck, then you're going to have a stable setup. But it did make a difference. Adding the raising center of gravity at the front did in fact stabilize the entire setup, and it was good. So I don't think you can see really easily with the models that it still got speed wobble, and this was even speed wobble with a 45-45. With the normal Curfboard, it's probably going to have a 45-60, which is going to turn a lot more and probably get speed wobbles at a lot lower speed. However, that's comparing apples to oranges, because we're talking about a surf skate truck. And as far as surf skate trucks are concerned, they're all going to share that hugely high turning or pivot angle at the front with lots of turning. And even the sweeping side-to-side motion, they're all going to share that to some degree as well. So as far as the family of surf skate trucks, I think it's definitely got, it's probably going to have a lot less speed wobble than some of the other boards out. Okay, one of the ones I want to address was the no adjustments of bushings or springs. Now, it states it as a good thing, and it can be a good thing, but it's also a bit of a double-edged sword. Adjustments are nice, and making adjustments are nice, and when I've gone through and discussed some of my design ideas with friends and our crazy kooky truck ideas, the ideas that we always drop are the ones you can't adjust, and there's adjustments just really good. Even if you don't really need it as much. And these trucks, if we bring up the skipper point, one of the other points it makes is self-regulating depending on the rider's style and weight. And that is also true. That's true of any raising center of gravity style setup you have, because the rider's weight acts as the return to center. That's the force driving the return to center. So if you have a rider that's twice as heavy, the return to center force is twice as much, and so it really levels the playing field and doesn't require as much adjustments for the rider. But adjustments will still allow you, to make changes based on your preference, not just your weight, and other, and depending on your style, the discipline, or how you want to push, or just how you want to customize things. So adjustments are never bad, even if you don't need them as much as other stuff. So as far as no adjustments of bushings or springs, I would probably grade that as an overall negative, even though there are some positive things to say about it. Adjustment's always good. Even so, you don't have to adjust bushings and springs, but at the same time you can't. So this other one is no wear and replacement of bushings or springs. So this one also has kind of two sides to it. I think this one's an overall net positive because having to replace bushings and springs is not good, and having the ability to replace bushings and springs isn't really beneficial. But the thing that replacement parts do have a good use for is protecting the more expensive parts from wearing out. So the good example of that on a traditional truck is the pivot cup. The pivot cup protects the pivot, and the actual pivot on the truck is never going to wear out. 25 years down the line, you could ride the truck every day, and as long as you replace that pivot, it's brand new again. Whereas the Curfboard, if we take a look at it up close, it's got these huge pivots that are long, and they've got lots of surface area on the inside, lots of wear surface. So they'll last a very, very long time, and I have no doubts about their robustness, but they will wear out from everything I can tell. I don't see any way of replacing them when they start to wear. And when they start to wear, they'll start to develop slop, they'll start to develop noise. It'll start to be a pretty unpleasant ride. And I don't think that'll be very fun. I don't think that's a concern about saying, oh, I do want to buy this board, is it going to last? I mean, it's not going to wear out fast. As far as the point of no wear of bushings or springs, I mean, I'd rather have wear components I replace than wear components that I can't replace. And then, I guess, high quality design and engineering in Germany. So this design is actually the same guy that made the BMW Street Carver, which is really cool. So I think the execution of the design is also going to be really well done. So let's see, do I have any last thoughts? One other thing, I guess, is I would be concerned about how rough and how much vibration is in the Curfboard. So normally when you have a traditional truck like this guy, the hanger's basically suspended in this body of urethane. It's got the urethane over here, and it's got the urethane in the pivot cup, and the bushings actually do a lot to dampen the vibrations. And basically all purely mechanical trucks with metal on metal joints have a lot of vibration. And the Curfboard has a large cantilever, so it has some opportunity to have some built-in flex, but I don't think it really does because it's the way it's got the aluminum body with this huge hinges. So you're not really going fast. Vibrations become a much bigger issue the faster you go, and especially if you're doing beaches and boardwalks and all nice groomed, smooth stuff, or riding it indoors like they are in the video. The vibrations are never going to be a problem. But I think it is something I want to address and bring up as a potential drawback, is the amount of vibrations you can receive from a metal on metal mechanic construction. And let's see, I think that's all the little points. Overall, would I recommend the truck based on what, I haven't ridden it yet, based on my models and speculation and stuff? I would say it's probably a really good surf skate truck. And I believe if you have a lot of boards and you just like to have different things, it's probably a really good thing to have in your collection. I would love to have one in my collection. I wouldn't want to probably pay the full price. I would like to buy the truck separately without buying a complete, which is I don't think an option I have at the moment. I have no need for a complete, but I'd love to mess around with the truck. Yeah, for a surf skate truck, it's probably It seems like it's a really, I don't see any inadequacies. It's adequate, and it seems good, and it could be really great. But beyond surf skate, I wouldn't, it's like I said, it says stability, no speed wobble. I mean, I wouldn't take that past the world of surf skate. That claim past surf skate. It's not going to be a downhill truck. It's not going to go fast. It might go faster than other surf skate trucks, but it's not going to go faster than your normal longboard truck. So there we go. That was long and exhaustive and a lot of work. So hopefully you stuck around to the end and you learned a lot. Even if the Curfboard's not the sort of truck you ride, hopefully you kind of appreciate the sort of technology that goes into designing something like that. And maybe stick around and watch a couple more videos. That helped me a lot. So there you go. Longboard technology. Over and out.